In this video, we're going to be talking about permutations and combinations. So first, let's start with some vocabulary. A permutation is basically an arrangement of objects where order matters. And we're going to be using our calculators today, so grab them if you have one nearby. And we're going to use our calculators to help us calculate permutations. Basically, what it can do is calculate the total number of arrangements that could be made, the total number of possible arrangements. So the formula for a permutation is NPR. The N and R are kind of written as subscripts. They're smaller. They're not in line with the P. And the formula is N, this is called factorial. We're going to talk about that in a second, over N minus R factorial. One key thing to note is that N represents the total number of objects, whereas R is the number of objects that are used. Now, a lot of people get confused between permutations and combinations. Here's the key difference, that in a combination, it's a grouping of objects where order doesn't matter. And we'll be looking at some real-world examples to make sense of that too. Okay, the formula is quite similar. So we have NCR. It's equal to N factorial over R factorial times N minus R factorial. That's basically the math that your calculator is doing when you use your calculator to find permutations and combinations. Okay, so you could use your calculator in place of that formula. And once again, N is the total number of objects, and R is how many objects we're going to use. So we saw that exclamation point symbol. That symbol is factorial. So factorial is the product of all natural numbers from n to 1. So for example, if a problem has 4 factorial, that's 4 times 3 times 2 times 1, or 24. So when we look at problems today, let's say we look at a combination problem, we're going to be putting NCR, and we'll change N and R to numbers, in our calculator. But what I want you to see is that this is the math that your calculator is actually doing behind the scenes that we can't actually see. All right, so permutations and combinations can be used to calculate probabilities. Probability is just the likelihood that a particular event occurs. And just a reminder, the probability of any event is the number of favorable outcomes divided by the number of possible outcomes. So we're going to look at some sample questions, 8 sample questions in this video. The last 2 are going to have to do with probability. All right, let's look at sample question 1. Would the following best be represented by a permutation or combination? The number of ways you arrange the letters in the word math. So think about if you are arranging or rearranging these letters in the word math. Maybe you're going to have ATHM. Or you're going to have AHTM, right? We can create different arrangements. But the important thing there is that the order matters. It matters what order those letters are in. So this is a permutation. Number 2, would the following best be represented by a permutation or combination? The number of ways to arrange the first, second, and third place winners in a race. Let's think about that. Does the order matter? Yes, absolutely, right? The person who wins first should be distinguished separately from the person who wins second or third. So since order matters, this is an example of a permutation. You'll notice here that we don't have a total number of, in this case, participants in the race. There's nothing we can calculate on this problem. You'll see the difference in number 3. All right, number 3, determine whether the following is best represented by a permutation or combination, but then we're going to solve. So it says the ice cream shop has 10 options for toppings. How many ways can Mary select 4 toppings for her ice cream? So the order doesn't matter. We're just grouping all these toppings together on top of her ice cream. There's no particular order that makes a difference. So this is going to be a combination. And the way we're going to set up our combination is that there are 10 options. And I think about the C as choose. She's going to choose 4. And we can calculate this. We're going to use our calculator. But remember on the previous slide earlier in the video, you saw a formula you could use too. So to find the C, the combination button, I'm going to hit the math button on my calculator. I'm going to arrow over to PRB for probability. and you'll see it there if you're following on my calculator screen as choice 3. When I select that, it's going to automatically kind of go to that first spot where I'm going to type in n, so that's 10. In the second spot, it's 4. Hit enter, and we get there are 210 different ways that Mary could select 4 toppings based out of the 10 options. Number 4, same idea, determine if it's best represented by a permutation or combination, and then we're going to solve. 6 students are running for office. How many ways can 2 students be awarded the offices of president and vice president? Well, similar to that race question before, the order matters, right? There's something distinguishing president from vice president. So we have 6 students. I think about the P in this case as pick. 6 students, we are going to pick 2. Okay, so the order matters. So I'm going to do math, arrow over to probability, and now it's choice 2 this time. I'm going to type in my values, and I get that there are 30 ways that I could select 2 students for president and vice president. All right, number 5. Same idea. It says how many different 5-letter arrangements, this is a key word for permutation, by the way, anytime you see arrangements, can be made using the letters of the word fruit. Okay, well, the word fruit has 5 letters, and we're going to be picking 5 of them. We're just going to rearrange them. So this is a permutation. So think about it, the order matters, right? It matters what letter comes first, then what letter comes second, and so on. So in my calculator, I'm going to do math, probability, choice 2. So 5p5. And I get 120 arrangements that are possible. Number 6, same question again. A committee of 5 members is to be randomly selected from a group of 18 students. Determine how many different committees can be formed. Just like on the previous question, how arrangement I said is a keyword for permutation, committee is a keyword for a combination. So there are 18 students. We need to choose 5 of them. And I'm going to type in 18C5 in my calculator. And I get that there's 8,568 different committees that could be formed. All right, for our last 2 questions, we're going to use permutations and combinations, but we are also going to incorporate probability. On these questions, I would try and think about it logically rather than memorizing some formula, but think about the idea that the probability of any event is the probability of the favorable outcomes over the probability of total possible outcomes. All right, there are 7 boys and 8 girls on the bowling team. If 2 students are chosen at random to be team captains, find the probability that both students are girls. Okay, so think about this is that we want the probability that they are both girls. And I'm going to start by creating my fraction because probability, again, is the number of favorable outcomes, like the outcomes we want, over the number of possible outcomes. Okay, well, we want both of them to be girls in this case. So for favorable, we want to take the 8 girls and we want to choose 2 of them. The order doesn't matter. They're both captains. They have the same role. For how many total possibilities? Well, there's 15 students, and we are going to choose 2 of them. All right, so we are going to put this in our calculator. I'm stacking my fraction, so I did alpha y equals choice 1 to get my fraction bar, and now I'm going to calculate this probability. So I have 8c2. That's divided by 15c2. And hit enter. And then I'm just going to convert this to a fraction. And I get my answer to be 4/15 as the possibility that both are girls. All right, our last question. Chelsea is randomly creating a 3-digit passcode where each digit is a number from 0 to 9 with no repeating digits. What's the probability her passcode is 123? All right, so we want the probability of the passcode being 123. Let's think about how many total possible outcomes there are here. Okay, so there are 10 digits, correct? So we have 0 through 9, so that's 10 digits. And she has to, in this case, pick 3 of them. Okay, the order does matter in a passcode. How many of these options are going to be 1, 2, 3? One of them, right? That's the favorable outcome. We're given an exact answer here. We want it to be 1, 2, 3. So this is how we're going to calculate our probability. So again, the numerator is because there's only one way to get 1, 2, 3. Okay, because order matters. And the denominator is because we have 10 options for digits and we're going to pick 3. All right, so let's calculate this. So this is 1 over 10 P3. Hit enter, and I'm going to turn this to a fraction. And I get the probability of her password being 123 is 1 over 720.